Have you ever wondered how a router, faced with multiple ways to reach the same destination, decides which path is truly the best one to use? It is more nuanced than simply picking the shortest route. Administrative distance is more important than a metric when a router receives information about the same destination from different routing sources or protocols. In these scenarios, administrative distance acts as the primary tiebreaker, determining which source is considered more trustworthy and therefore, whose route is installed into the routing table. The core reason administrative distance takes precedence is because it represents the credibility or trustworthiness of a routing information source. Imagine different news agencies reporting on the same event. Some are more reliable than others. Similarly, routing protocols like Open Shortest Path First or Border Gateway Protocol, along with static routes or directly connected networks, each have a default administrative distance value assigned to them. A lower administrative distance indicates a higher level of trust, meaning that route will be preferred over one with a higher administrative distance, regardless of how good its internal metric might appear. Network administrators actively use administrative distance to steer traffic and establish backup paths. For instance, they might intentionally configure a static route, which typically has a very low administrative distance of 1, to override routes learned from a dynamic routing protocol. This allows precise control over preferred paths, ensuring that critical traffic follows a desired route, or to create a reliable failover mechanism if the primary path becomes unavailable, making it a powerful tool in network design. A key application of this principle is in scenarios involving route redistribution, where routes from one protocol are injected into another. When routes are redistributed, their administrative distance often needs adjustment to ensure proper path selection and to prevent routing loops or suboptimal forwarding. Another example is using floating static routes, which are static routes configured with a higher administrative distance than a dynamic protocol, only becoming active if the primary dynamically learned route fails. Understanding administrative distance empowers network engineers to design robust and predictable network topologies. It provides the essential framework for evaluating the overall trustworthiness of routing information, allowing for deliberate choices in path preference and ensuring network stability across diverse and complex routing environments.
If you love understanding how the web works, like, subscribe, and stay connected with us.